So here we have our 8-bit adder. It takes in two 8-bit numbers, sign extends them, and adds them together. If we add a negative 128, it shows that by sign extending it, and then add 0. The actual mechanism just adds unsigned. It's the metadata that allows us to know what the 2's complement numbers addition means. So just adding some small numbers. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. Okay, all good. If we switch on some of these over here, we get this is negative 8. If we add 8 here, we get 0. Nice, just as it should be. And it also works for both negative numbers. If we add, if we start flipping switches over here, we get that negative 8 plus negative 8 is in fact negative 16. It can also, so it takes the carry, moving it over to the left, and when you get all the way to the left, then it overflows. Like for instance, a more simple example, add that. There's an extra carry bit that went off the end and was not represented. This represents an overflow, which you can detect. When the last number, and the last light, and the second to last light are different, that means that an overflow occurred, as is the case here. Negative 128 plus negative 128, it cannot represent a number like that, so it simply represents what it can, and we know from this that there's an overflow, and the 2's complement number it's showing is 0, exactly as we thought it would.